Hello, 8 Purple. I want to start today with reviewing the two models that we've looked at for moon phases. This is kind of what exactly you did yesterday in terms of if this is a flashlight, this would be you, and then this would be whatever sphere you held. So this is the model that I was hoping you would do in some kind of dark place. So when the moon is between you and the light, or in this case the Earth and the Sun, all the light hitting the moon would bounce back towards the sun and none of it would hit the Earth. And so that would correspond with a new moon. And then as the moon goes counterclockwise around, you would see a little bit of that shade of the unshaded area of the lit area on the right side of the moon. And so that would make a waxing crescent shape. As we get to 1/4 of the way through the revolution, that corresponds to a first quarter, and you can very clearly see how that lines up. If you're on Earth looking at the moon, you only see the right side lit up, and you see the left side that's in dark, and that's what this first quarter looks like. And then as you continue to spin that sphere around you, you would start seeing more and more of that lit side until eventually you saw all of it. You saw 100% of it, and that is a full moon. And then at this point, we're going to kind of reverse the trend, and the side of the moon that we see that's unlit will start to get smaller, or I'm sorry, the side of the moon that we see that's lit will get smaller and smaller. So this would become a waning gibbous, and then we would have a last quarter down here, and then a waning crescent where we see most of the dark side and a little bit of that lit side, and then finally we're back to a new moon. So that model, it does a great job of showing you the two different perspectives of how we can see moon phases, and that's going to be really important for adding this third variable that we're going to talk about today. On Monday, I had you take a look at this exit ticket. I tried to show this to you yesterday, but my video lecture, for whatever reason, got out of sync, and I couldn't use it. So anyway, this is what happens. This is kind of a good explanation of how you can view the stages of the moon in their orbit. So again, here's our model with our sun down at the bottom this time. So that means the new moon is going to be here, and then it's going to rotate around first quarter, full moon, last quarter. So whenever the moon is in this position, whenever it's going from a new moon to a full moon, that would be considered waxing, and you're going to see more and more of that lit side. And then when it starts coming back this way on the second half of its revolution, that's when it would be waning. When it's on the side of the Earth that's daytime, that would form the shape of a crescent, and when it's on the side of the Earth that's in nighttime, that would form the shape of a gibbous or a full moon. Okay, so let's I'm going to count backwards from 3 and see if you can't name the phase before I do. All right, 3, 2, 1. This is a waning gibbous. 3, 2, 1, full moon. 3, 2, 1, waxing crescent. 3, 2, 1, waxing gibbous. 3, 2, 1, waning crescent. And then the other thing that I tried to do yesterday, although it didn't work out, was see if you can't figure out where in the orbit the moon is if just given a picture. So here, because we see so little of the moon and only a tiny little sliver that's lit up, it would be right about there. Here we're seeing more of the moon lit up, but it's still only on the right side, so it's a crescent. So using that model that we just talked about, it's going to be on this side of the Earth, and because the right side is lit up, it's going to be waxing, so right around there. This is a first quarter moon, so it's going to be at the 25% mark, 25% of the way around. So what moon phase is this? So if you're on the Earth right here, and you're looking at the moon, you would see the left side lit up, and most of it would be lit up, but you'd see a tiny little fraction that's on the right side that's dark. So that's going to be a waning crescent, waning gibbous. All right, so our third variable is that we're going to introduce time. So a lot of times we typically associate the moon with nighttime, but there are plenty of pictures, and I'm sure that you've seen that the moon is out during the day as well. So we're going to try to understand what is the relationship between the time of day, the moon phase, and the position in the sky. So these are the kind of the 3 variables that come into play when talking about moon phases. If you know 2 of the 3 variables, you can actually figure out the third. It's kind of like a math equation. So before we get started, let's just identify what I mean by moon position. So everything rises in the east and sets in the west. And here in the northern hemisphere, everything moves across the southern sky. So this viewpoint right now, this vantage point of looking at this barn, that's looking south. And here we have a sun rising in the east, going up to its high point right there, and then setting in the west. But you can imagine that that could be a moon as well. So our first position is going to be rise, and then a few hours later, it will be at mid-rise, and then at its height of its journey across the sky will be the zenith, and then it's going to start setting, so that will be mid-set, and then our fifth position will be set. So a quick reality check, is the moon slash sun or any other object really rising and falling? Definitely not. The Earth is rotating so that it faces the sun or moon more directly. So I guess the next time you see like a beautiful sunset, it'd be more accurate to say, look at that beautiful Earth rotation out of the field of view of the sun. Okay, so here's a cool animation of what's happening. This camera is set up so that it's locked to the stars instead of on the planet. So this is really like the planet kind of tilting and rotating underneath the stars, and it gives a good idea. It's a good reminder of what's actually happening. All right, so here are 8 distinct phases, and this time our sun is on the left, so that's going to change the position of the new moon, because the new moon is always going to be between the sun and the earth, and the full moon will always be on the far side of the earth from the sun. So make sure that you always orient your models correctly, because that's going to be important. Okay, so what is a phase of the moon? The thing about this, I guess first off, if we're looking at the moon, that means that the right side is lit up, and it's mostly lit up, so that's going to be a waxing gibbous, like that. This red dot is where we currently are, so that's covering like Connecticut, or it's pretty big, so it's covering New England. But anyway, when you're on the red dot, you cannot see the moon until you cross this red dotted line, until you're on the side of Earth that is facing the moon. So as the Earth rotates, we're only now going to be able to see the moon. And when you cross that red line, we would consider that the rise. So the moon is now rising for these people in the red dot. Right about here, it'd be at that mid-rise position. When you're close to the moon, when you're directly underneath it, that would be its zenith, that's its high point in the sky. And then as you go this way, you'll be at mid-set, and you'll notice if you're on this red dot, you'd have to look kind of west to see the moon. And then finally, as we cross that red line again, now you're definitely looking west, and the moon is setting in the west. And so that's going to be how that how that occurs in terms of the moon's rising and setting as the Earth spins. You can also separate and segment the Earth into 24 different hour cycles, and as the Earth rotates through them, you can kind of see what hour you might be at. And so here, where you're crossing this line from light to dark, that would be about 6 p.m. You'd be going through nighttime. Halfway through the night is midnight, and then again in the morning time, when you're crossing that line, that's going to be 6 a.m. And then finally, you'd have noon right about halfway through the daytime. So you can separate your Earth into those 24-hour segments as well. So that's going to help out with tying in that last piece of the puzzle. Let's uncover these times. So right here, this is the side of Earth that's in daylight, so it makes sense that as you're halfway through the day, right, as you're traveling halfway through the day, that would be noon. And then as you continue on, as you're about to close out the day, as you cross that threshold from daytime to nighttime, that's going to be 6 p.m. So halfway between noon and 6 p.m. is 3 a.m. So these increments are going to go in 3 hours. So that's going to make this 9 p.m. That would make this midnight, right? You're halfway through the daytime, or halfway through the nighttime. This would be at 3 a.m., 6 a.m., and 9 a.m. So what we're doing here is we're adding this layer of time to our orbital model. And now that we have this red line, we can kind of see that the moon is always going to be out for 12 hours. We're going to be in its field of view for 12 hours. And when the moon is in this position, which is a waning gibbous, we cross over that red line threshold at 9 p.m., which means that a waning gibbous rises at 9 p.m. It's at its mid-rise, right about here at midnight. It's directly overhead at 3 a.m. It's at its mid-set point at 6 a.m., and then a waning gibbous will set completely at 9 a.m. in the morning. And then the next day, when this moon has shifted its position, all of this will shift as well. And so you can kind of see what's going on here, right? As the moon rotates around or revolves around Earth, the times at which it rises and sets and is directly overhead also change. So that's what today's class is going to be trying to get at. So if you'll notice, when you have a moon in a waxing crescent position, much of it is out during the day. So let's grab our Earth again. Can I rotate this guy? Oops. Well, I don't need to do that. All right, so if you can see, this red dotted line, as the Earth spins, the vast majority of the time that you can see the moon, you'll also be in daytime. So waxing crescent is mostly out during the day, except for this small little sliver of time over here when it's setting, and it will be out at nighttime. So same thing over here. We have a waning crescent, and as the Earth spins and you're that red dot, as you cross that threshold, it will be out at nighttime. But then as soon as you come into daytime, there's the moon again, and it's still there. And as the Earth rotates, you can still see the moon until you cross out right at about 3 p.m., right? Because this dotted line it points to the 3 p.m. line. So there's a large portion of time where the moon is out during the day. Okay, so let's do a quick recap. When can you see the moon in the sky? Well, the moon is in the sky for 12 hours every day. You can see it as long as you're on the side of the Earth that's currently facing the moon. And are there any hours during the day when the moon is never out? The answer is no. The moon can be out, and it can be seen at any time, at any hour, so long as it's in the right phase. So we typically associate the moon with nighttime, but that's not true. It's out just as much during the day as it is at night. So let me go over today's assignment. The first thing that I have you guys do is look at this model. You'll want to print this out, and you're going to cut out the Earth on the dotted line, and you'll cut out the moon on the dotted line. And the Earth, right at that green pin, you're going to put that in the center of this wheel and put like a pin through it. If you have a brass tack, that'd be great, because that will allow you to spin the Earth on the model. But you could use a paper clip or anything that's sharp. You could even use a pencil and kind of hold it down, and spin the Earth that way. So you may have to get creative if you don't have a brass tack or any kind of tack that you can poke through there. And then the moon, you can put in its position anywhere on its orbit to change its phase. So for example, let's go back to my slide here. We'll go to this one. So this is basically what you're looking at. And so with the Earth, you can spin that. You'll be able to spin that, and you can see whatever time of day it is based on the position of the red dot. So the red dot here would be at noon. Here would be 3. This would be 6 p.m., 9 p.m., midnight, 3 p.m., or 3 a.m., 6 a.m., and then 9 a.m. And then whatever moon phase you want, you just put your moon in the right spot. Here would be the new moon, a waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, last quarter, and then a waning crescent. So that's basically what you'll be doing with your model. And then what you'll end up going to do is fill in this sheet, this pattern grid, and you'll find that as you fill it in, you might see a pattern that will allow you to fill it in even faster. So let's do this first couple of boxes for you, so you understand what I'm talking about. So the new moon. Let's get our moon into position for a new moon. So this is what a new moon looks like, and we want to figure out. Let's put this over here. We want to figure out, when does a new moon rise? When is a new moon going to rise? Well, the first time, this red thing isn't on there, but it's not too difficult to figure it out to make one yourself. The first time you spin into the field of view of the moon is right when you cross this threshold, and that's at 6 a.m. So what you'd write in this box right here is 6 a.m. 6 a.m. And then it's at a mid-rise. Well, it's at its zenith when it's directly overhead. So right there is when the moon would be directly overhead, and that corresponds to a noon time. So we're going to say 12. We're going to say 12 p.m. And then it sets right here when you cross this red line again at 6 p.m. So we'll write 6 p.m. as the moon set. And then the increments, the mid-rise would just be the halfway point. So this is going to be 9 a.m. And this would be 3 p.m. And then you'll move, and so when you're going down to the waxing crescent, you're going to take this moon and move to the waxing crescent position, which is right there. And then everything will shift. So you'll no longer, let's move this guy. So at this point, you'll no longer, if you rotate at 6 a.m., you'll notice that you can't see the moon anymore. So when it's in a new moon position, that's when it would have risen, but it's not there anymore. So you have to rotate a little bit further in order to see that moon again. So now it rises at 9 a.m. So you'd write 9 a.m. here. 9 And so that's the idea. You'll fill it out and you should see a pattern that emerges pretty quickly. So that's it. If you have any questions, please let me know, and thanks for watching.